In this video, we're going to look at the heating process on a psychometric chart. For this example, what we're going to do is we're going to heat air from 32 degrees to 75 degrees. So you can see down here we've placed the starting point at 32 degrees, and the dry bulb temperature is listed across the bottom. Dry bulb temperature is the same as what you would read on a thermometer. And so these conditions are listed here, and the lines are vertical. So we've got our starting point at 32. Now we've added the heat. And so we started at 32. We put enough heat into this air that we warmed it from 32 over to 75. As you can see, it's a perfectly horizontal line at right angles to our temperature gradients here. And now you could read the new temperature off of this chart down here on the dry bulb and see that it's 75. And it had the effect of, we changed the temperature of this air 43 degrees, and that's how it would show up on a psych chart. So let's look at relative humidity. These curved lines that you see on the psych chart are the relative humidity lines here. So this is 20%, 40%, 60, 80. And this one here is the saturation curve. This is 100% RH. Now we started with air that was cold, 32 degrees, basically freezing. And at that condition, we were at 75.8 percent relative humidity. 32 degree air will not hold very much moisture. It's cold, and so for the amount we had in here, this air was very close to saturation. Now as we warm that air up, you can see we crossed all of these horizontal or these relative humidity curves, and we finished over here at 15.6% RH. And that's because this air is much warmer now. It's capable of holding a lot more humidity, and so relative to full saturation, there's not that much humidity in the air because it's 75 degrees. It's much warmer. In this example, right here, we want to look at the humidity ratio. Now, humidity ratio are horizontal lines across here, and the scale goes up along here. It is the ratio of pounds of water to pounds of air, or in this case, grains of water to pounds of air. Now, a grain is just a unit of measure. There's 7,000 grains in a pound, and if you use grains, what you get are whole numbers here as opposed to a very small fraction. Remember that for most air conditions, we're talking about 1 to 2% of the air is water by mass. It's a very small amount of water molecules in a typical cubic foot of air. Because all we did was add heat to the process, we didn't add any more water to it. There was no humidifier. There was no way to add water to this process. It's a perfectly horizontal. So as we increase the temperature here and we cross these lines, there was no movement this way. So we started at 20 grains of water per pound of dry air, and we ended at 20 grains of water per pound of dry air. So this is, in the winter, is an example of why buildings seem very dry. As we warm up outside air and bring it into the buildings, there's very little humidity in it, and so it tends to dry the buildings out because there's no source for humidity. Now, the last thing we want to look at is enthalpy. Enthalpy is the internal energy of the air. Now, we started down here at a fairly low energy point, and we did work on this air. We added heat to it. We did it with a coil or a furnace or an electric heater, and that energy was absorbed by the air. That's why it warmed up from 32 to 75. And what we did was we added 10.4 BTUs of energy for every pound of air. Now, this number is critical for the actual sizing of the equipment. The psychometrics start by allowing you to say, I have air at this condition. It would be more comfortable for the occupants if I did this, and you can work out where you want to be. And then you can use the psych chart to actually say, what do I have to do to the air to change its properties to get it to the condition that I desire? In this case, you would have to add 10.4 BTUs of heat for every pound of air that runs across. So that's it for heating process. Thank you very much.